Hi guys, welcome to week 11 of operating system course. We will be talking about security and protection operating system this week. This is chapter number 14 and chapter number 15 of your textbook. So this, as you can see in the course flow, going to be our last topic for this course. I hope you guys have learned something new in this course. I know it's a very detailed and comprehensive course. Most of our videos are more than 2 hours. I just wanted to give you a lot of information about operating system course, how things work. So I think we have covered a lot. We have there is still content remaining, just because of this online thing and so on. I try to cover almost everything that is included in your syllabus, but I wanted to cover some more things. Just wanted to give you some more information about how things actually work, so that when you go in the market you at least know, you have an idea how these things actually work. Although we have covered all our syllabus, but I really wanted to cover few more things if we had some more time. But at the same time, I didn't want to burden you too much with a lot of stuff. We already have a lot of things going on in this course. We had 3 assignments, we are going to have a project as well, and then final exam. So I think this course already is very heavy. That's why I didn't want to cover some extra additional stuff into it. So I expect you guys to have learned something new in this course. There are a few things that you might already know before coming to this course, but I hope when you leave this course, when you complete this course, you actually know what operating system is, how things work, what are processes, what are threads, what are the problems and limitations of operating system, how operating system has to deal with a lot of things going on in the memory, in the file systems and mass storage structures. And finally, today we are going to talk about security and protection. It's a very big topic, because I've combined security and protection together. There are 2 different chapters of your book, but since we don't have too much time left and I wanted to cover some sample exams in week number 12, so I'm gonna just close this course over here in this week. But as I said, we have covered our syllabus and we have gone through all the major topics in operating system in general. So we have done a pretty good job. You guys should be proud of yourself that you have reached up till here, and you have done an excellent job. I want to congratulate all the students that you have done a brilliant job when it comes to assignments. Although I do want to mention that these assignments were a bit easy, if you ask me, because normally if it was a regular time, it was a traditional class where we are physically available and we can talk to each other. These assignments would have been a little bit to a next level, a bit tricky. But since we are not here and the communication medium is not easy over here as well, you have to drop an email, you have to come to office hours, virtual office hours and so on. That's why I wanted to keep these assignments a bit on the easy side. But normally even if you go online and see some assignment questions for operating system, they are pretty tricky. Even when it comes to projects are not very tricky as they normally are in this course. I try to keep them a bit on the easier side. Again, just wanted to make sure that you guys are able to complete that in the allotted time. And I do understand that you guys, I mean, we are all very far from each other and it's very difficult to contact our classmates to form groups and so on. So I do understand all these limitations. That's why I did not put too much requirements in the project as well. So hope you guys do good with projects. There is only one assignment left, which I already gave you. I'm not going to go through assignment number 3 now because I've explained that already in last lecture, and I'm sure you guys are already working on that. But if you have any issues in assignment 3, you can always just contact me, drop an email or visit me in my office hours. One of the part of assignment 3, which I mean, you can always go to Google and find that out, but I'm going to cover one topic in security, especially in permissions, that is part of assignment number 3, which most of you already know because we have been using modern operating system for quite some time now. But I'm going to cover that in quite detail today. So if you are stuck on last point where we have to give permissions to our folders and files in Linux, especially for the root, then you will see that we are going to go do that today when we discuss about Linux file permissions, file and folder permissions. So this is it for your assessments, and again, congratulations, you have done a great job. Most of you are doing pretty well in this course. We are only left with our project and final exam. We are left with assignment number 3 as well, but I hope that that is not going to create a lot of problems for you. It's a pretty easy assignment. It's easier than assignment number 1 and assignment number 2, to be honest. So hopefully you guys can complete that as soon as possible, and then you are left with project and final exam. And as I said that I am going to cover a sample final exam for you next week. So you'll see how questions will appear, what you should expect from the final exam. But just to quickly summarize that, what I'm planning to do in final exam is it will be conducted on Blackboard, and it will not be a live exam. So I'm going to give you 24 hours and you have to go to Blackboard, sign into Blackboard, and just complete your exam in one go. So you can sign in anytime. If you're, for example, your internet is not working in the morning, maybe in the afternoon, maybe in the evening or at night, you can complete that exam. But you have to complete that exam in one go. So if you sit and sign into your exam, you have to complete that time. Make sure you do that. And exam, as I said, is not going to be live exam, obviously, because you have a window where you have to complete this exam, and that window is going to be 24 hours. So complete your exam anytime between those 24 hours. And exam is going to be open book, open internet. You want to find help, go to internet, but honestly, if you ask me, you won't have enough time for that, because it's a time constrained exam and you have to finish that exam within allotted time. So I would suggest you not to go here and then there, find too many things here and there, but keep your lectures handy, keep them with you. You might need help from them. And I'm not going to ask you to write a C or C++ code or Java code, but yes, I might ask you to write a pseudo code for me. So please be ready for that. Then this exam is going to be in 2 parts. I mean, there are going to be 2 sections. First section will be MCQ section, so there will be multiple choice questions or true false questions in that. So this will be one section. The other section will be short questions, so I'll ask you a couple of short questions that you have to answer, and you have to answer on Blackboard. So as I'm gonna solve one exam for you already in week number 12, so you will see how to answer the questions, and you will see how to attempt that exam. So hopefully I can cover more details in that, but for now, I mean, it's going to be between a window of 24 hours. It's not going to be a live exam, and you will have an open book exam. So these are the few important points that I wanted to cover today, because a lot of students are already asking me about this. So I wanted to make sure that you guys feel a little bit comfortable getting more information about the exam. And next week, obviously, I'm gonna make an exam and solve it for you, so that you get more comfortable about the exam. So that's for this. The other thing I want to cover is the schedule. So I've already put a project presentation schedule for you guys online. So I've already put an announcement for you. So if you go to course content in the course itself, you will see this file over here, operating system project groups. So you can download this file and have a look at this PDF file. So each group has been allotted a time, and you have to appear, all the 3 members or 2 members, if you are doing it alone, you have to appear between this time window, and then you have to present your project, and I'm gonna ask you a few questions at the end of the presentation. So this is the time slot for each group, and over here let me explain the first one for you. So this is project 1, means this group is doing project 1, which is, I think, Linux shell, if I'm not wrong. So they are doing project number 1. These are the members of the group. This is the team lead. So I try to put team lead wherever students have provided me that information. At some places you might not see this group lead, but if you are part of that group, you know who is the group lead. So this is a time. So it's going to be on Wednesday, December 2nd, 2020, and first group will be presenting. All the times are in PST, so make sure you appear according to that time. So first group will appear start from 8:30, and it will be 20 minutes for each group. So 5 minutes of quick presentation that they can give, and then 15 minutes for my question answer from each student, and we can see how we can still play with the time. But this is what I'm feeling, that this is going to be the pattern, but it depends obviously about how we're going to go about the time. So it depends upon the number of members in the team as well, and so on. But just make sure that this is the time for you. I have allotted the time. Some of the groups, some of the students, they haven't provided me any group, so I've put like this and their names are here. So if you are in a group, just drop me an email and I will fix this. But at least you have the idea. So this is how group presentations are going to be. Make sure you note your time. Do not miss this, because this is going next, since this is next week, and we will not have more chances, because next week is the last week before your final exam. So we need to finish the business, and if you don't appear, then you might be losing a lot of marks, which we don't want, right? So please do not miss that. If you have any trouble, for example, you cannot appear between this time, just drop me an email and we'll try to find an alternate time for you. But do not miss this presentation, because it's quite a lot of marks, right? So it's 30 marks, that's too many, right? So don't miss, and make sure you appear for this. And yeah, and by the way, submitting your final project on Blackboard is not going to help only. You have to appear for this presentation, because we have to see what you have done, right? So definitely you have to submit your projects on the Word file, in the Word file I provided you, before the deadline. I think that is 29th of November, if I'm not wrong. You have to submit that, and I'm going to mark that accordingly. But you have to appear for this presentation as well. So make sure you do not miss this presentation at all. If you have any questions, just drop me an email or we can talk about it. So that's for this, and that's for our course flow. I think it's time to move to the lecture now. So let's get started. We're going to talk about security and protection today, and we'll start with protection. Well, protection normally refers to controlling the access of a program, process, or a user, so that it has access to only the resources that it is looking for, right? So for example, if process 1 is looking for a printer, maybe PR1, then it should be given access to only this printer, instead of P1 getting access to the scanner as well, getting access to maybe other resources as well. So it's not a good idea to do that. Similarly, if a user is asking for permission or something to asking for a permission to access something, then the user should not be given access to everything. For example, if we talk about Linux, users are not given default root access by default, so they are not given root access. Root has access to everything, right? Because it's an administrator of the system. So users in Linux, for example, they are not given access to everything. However, root has access to everything. So if user is asking to get an access to /bin folder, for example, then user should not be given access to /etc folder, because we are giving access to the folder. So it doesn't work like this. So this means protection, right? If something is asking for something, give him that thing only. Don't give access to the other things as well, right? So this is the general idea of protection. So a modern operating system keeps these things intact. They take a lot of care about these things, and they make sure that protection is done in a right way, because right now, I mean, we know that these days one computer is being used by multiple users, right? So just take an example of your computers in your lab, right? So those computers are being used by different users. So files that are for one user should not be able to be accessed by the other user, right? So all these things should be taken care of. Old version of Windows operating system, for example, they were not built like this, so anybody can just go and start using it, because there were no users and so on. That time there used to be only one user, and anybody can go and use that. But now in recent modern versions of Windows, we do have users, so everything is built according to the users, and that's why Windows operating system is getting more protected now. It's getting more secure now. So this is the general idea of protection, and as I said that authorization and unauthorization is an important part of your protection. People who have authorization to access your system should be allowed to use your system, and others should not be allowed. Even on a single folder, if user 1 has access to that folder, user 2 should not be given access to that folder unless and until user 2 has something to do with this folder, right? So these all things are called protection. Now there are some principles of protection, and how we define it is a key time-tested guiding principles for protection is principle of least privilege. What this means actually is we give least privileges to a user to everything, right? So for example, if there is a user, we give user least privileges so that it can operate on that system, right? So for example, if there is user 1, we want to give access, for example, if user 1 is a user who is going to only execute programs, we are not going to give user the right permission just because we are giving the execute permissions to the user. So since user is looking to execute programs only, we give him only the execution permissions, not the write permissions, right? So that is called principle of least privileges. The permissions that user is asking for, give only those permissions, don't give other permissions. So this concept actually is called principle of least privileges. Now root does not fall in it because root has access to everything. Similarly, administrator user in Windows does not fall in it because administrator user has access to everything. And this doesn't only apply to users, it also applies to processes. For example, processes are given least privileges also because I mean, if process 1 is looking for printer again, then process 1 should be given access to the printer only and not the scanner. Why? Because if printer 1 has nothing to scan, then there might be a process P2 that is looking for writes or access to scanner, and since P1 is holding it, then P2 should wait for P1 to let it go, and P1 is just holding it, doing nothing with it, so P2 just keeps on waiting. So this is another way of telling what the principle of least privileges is. Now this is one reason that other processes might not get a chance to use the resources. The other reason is, for example, if P1 is using the memory RAM or a specific location of the RAM, and for example, this is location number 0, this is 1, and this is 2. So if process 1 is accessing location number 1, and for some reason process 1 exits or gets corrupted or halts or freezes for some reason, the other processes, for example, process 2 is writing at location 0, process 3 is writing at location 2, then at least these processes should be able to keep working, right? They should keep working because this memory location is the one only that is halted, that is being affected by process 1. P2 and P3 should be able to work on memory because they are working on a different memory location, right? Similarly, if you're working on Microsoft Word, for example, and Microsoft Word is doing something, and then Microsoft Word process it halts or it freezes, it should not freeze the whole system. Only that process should freeze, and because freeze can occur for so many reasons, maybe because this process is looking for some resources, maybe it's looking for memory location and somebody is already writing on that, or so on, right? So if a process freezes, that it should not freeze the whole system. That's another reason why we need protection, and that's why we need least privileges for the processes and for the users. So that's why if we do a least privilege principle, then it means that if a process freezes, then it will not freeze the whole system because that process is given access to only the resources that that process is looking for, and the other resources are still available for other processes to work, right? So this is another reason, and this is another advantage of least privileges for users and for processes. Now as I said earlier, Windows is now using a mechanism of Unix. Unix has been using this for, I mean, since inception, if I'm not wrong, that they are using the user privileges or accounts for managing everything in an operating system. So each user has an account, and that account manages everything for that particular user. Well, Windows is using something pretty similar now. So each user has an account now, and everything is related to that account. The files, the documents, everything is related to that account. So this helps I mean, in keeping safe the account of one user from another user. So that's why protection helps in this way as well. Now the other thing is domain of protection. Now as we know that our computer system is not only about users, they are about processes as well, they're about objects as well. Now objects obviously can be processes, they can be users, they can be resources. Object is a very generic word we normally use in operating system, that is to hold everything, right? And a computer system can have many of them. So if we don't use this word processes here, we can still say objects. An object can contain processes, resources, it can contain users, it can contain files, it can contain directories, and so on. Now, a domain of protection, what it means is that each object should have a separate name. So if this is process 1, there should be no other process that has process 1 name, right? So each process should have a separate unique identity. Now that identity in operating system is normally the process ID. Each process has different ID, and similarly each user has a different ID. We normally call it UID, and so on. Similarly file ID, and so on. Similarly we have resource ID, and so on. So everybody should be distinguished from others, and this is the way operating system distinguishes between different processes, different resources, different users, different files, different directories, and so on. Now if operating system is not able to distinguish between different processes, then the whole concept we just talked about protection is not going to work, right? So if every process is just a process and it has no ID, then operating system will not be able to manage those processes properly, right? Similarly, about the resources, I mean, each object has different operations, right? So process might execute something, process might write on something, process might read from something, right? So it has different operations. So if we talk about CPU, for example, a process is being executed using a CPU. So CPU will work on a process to execute that process, right? Similarly, if we talk about memory, memory can be written, can be read, right? So these are some of the operations on memory. Similarly, CD-ROM can be read as well. Now we do have writable CDs as well, but normally CD-ROMs are used for reading only. So different operations are being performed, and these operations should be monitored in such a way that they are protected. So if CD-ROM is only for reading, then there should be no process that is trying to write on that, right? Similarly, if CPU is for execution, no process should be there to write on CPU, right? So this whole thing is called protection. So if a resource is meant to do certain operations, then processes or users should not be allowed to do other operations on your resources. Just like as I told you that CPU is there only to execute things, so processes should not come and try to write on a CPU, because it's not going to work. This is not an operation for CPU. This also falls in protection, and normally this is called domain of protections, right? Now again, I mean, this is the whole thing I just told you, but then domain of protection also include other things like scope, right? So for example, if process P invokes a procedure, so there is a method, for example, or a procedure, and process P is running that procedure, then this process should have access to only this process, instead of giving access of all the processes in operating system to this process, right? Similarly, this procedure or method, a method, should have access only to the variables that are inside this variable, or that are given to this variable through a parameter, instead of having access to all of the variables. And this is normally known as need to know principle. Now normally what happens is the process should be able to access only those resources that it needs, right? So process should not be given resources, as I just mentioned, that it should not be given resources that it is not looking for, or that it is not asking for. And that's why it's called a need to know principle. So process should need to know only those things that it is looking for, right? So for example, if some process comes, that is, for example, if there is a process that is only used for printing, and we start giving it information about how to execute a program, how to write a program, how to read a program, it's of no use, right? Instead, what we are doing is we are destroying our protection for the system. So I already gave you several examples of these things. These are just repetition. I wanted to include these slides just to give you more information about these things. But I think I have already given you enough information of what a principle of protection is, what protection and what a domain protection is. Next thing is the domain structure. Now before I go to domain structure, what I wanted to tell you is about domain. So what a domain is basically set of rules, right? Set of rules or set of rights. So this domain basically is set of rules or set of access rights, right? Now what is an access right? Access right is basically the name of an object and the rules or the rights given to that. Now let's understand this with an example. So we have a domain. Let's consider we have a domain D1, and inside this domain we have these objects: object 1, object 2, object 3. And these objects can be users, these can be processes, these can be files. That's why I want to keep it general, that these can be anything, right? So let's keep them general. So object 1 in domain 1 has read and write access, right? So in domain 1, so this whole thing is domain 1. So object 1 has read and write access in this domain. Similarly, object 2 has execute rights in this D1. Similarly, object 3 has read and write access in this domain. Now let's talk about the other domain. Now if we talk about the other domain, let me just erase this. So if we talk about the other domain, there is another domain D2 and D3. Again we have same objects, object 2, object 1 and object 3. Now in D2, domain 2, I will tell you the real world example of this as well. Let me first explain this and then I will give you the real world example of this. Now in domain 2, object 2 has write permissions. Similarly, object 4 has print permissions. And there are no permissions for object number 1 and object number 3 in D2, right? Similarly, in D3, object 1 has execute permissions, object 3 has read permissions, and object 4 has print permission. If you see over here, this is an overlap, which means that object 4 can still print even if it's in domain 2, or it can still print even if it's in domain 3. But object 4 is not available in domain 1, which means that object 4 cannot work in this domain, right? So this is the general idea. Now let me give you an example, real world example of this. Now in real world example, what I'm going to say is, let me take this domain. Now as per this domain, let's assume that this basically is an environment. So I have a Linux computer. This is a Linux computer, and in this Linux computer I have 3 users. Let's call this user 3 and user 1 and user 2, right? So we have a computer, let's call it maybe C1, computer 1, and this computer 1 is actually a domain. I'm calling it a domain. So it has 3 users inside. User 3, when it's in this domain, when it's in this on this computer, for example, this user can be John, this user can be, I don't know, Mary, this user can be Steve, right? So these are 3 users. They are using this computer. We call it computer C1, or since we are talking about domain, we can call computer 1 as domain 1 as well. So John has read and write access on this computer, so he can read on any file, he can write on any file. Similarly, Mary can read any file, can write any file. Steve has only the execute permission on this computer. All right, so Steve cannot read or write any file. Steve can only execute this file. Now let's talk about this domain 2 and 3. Same users. So there are same users. O2 was Mary, and we don't have O4 here. That's fine. So this is John, and we have O3, which is Steve, right? So let's assume that there is another computer which is C2, or we call this a domain 2 computer as well. On this computer, Mary has only write access. She doesn't have read access. I mean, normally you will have the read access also, but let's assume that it has only write access. So although Mary had read and write access, O2 is here, Steve. Sorry, it was Steve. It's Steve, and Mary was messed up. So this is Mary, and this is John. Okay, so Steve has only write access when Steve is on C2, right? And Steve has no access to computer C3, for example, or domain 3, because there is no O2 in this computer, right? Similarly, John had execute permissions in computer C1. So John can go and execute any program in computer number C. But John on computer 3 cannot execute programs. It can only read programs. So this is what I actually meant by domain. Now domain can be any environment. It can be a single computer. It can be a user account. So this domain can be a user account as well. It can be a file, it can be a folder. Now it depends what we are talking about. Now in domain, now that's why I'm saying that it's actually a set of access rights. Now are we talking about access rights on a file or a directory? Are we talking about access rights on a computer? Are we talking about access rights on a network? What are we talking about? But just wanted to give you a general idea that this is how it looks like. This is called a domain, and this is how we talk about permissions in domains. Now let's continue domain structure. Now as I just told you that each user may be a domain. I told you that a user can be a domain, a process also can be a domain, and a procedure may also be a domain, right? So account can be a domain, as I said. Similarly, there can be other things, but these are only few examples, as I just told you. So it depends upon what we are talking about. Now it all depends upon, again, the context. If we talk about processes, then we take domain structure differently. If we talk about user, we take them differently, but they have to be very, very specific to that account or a process or a procedure, right? Now I hope you guys understand what a domain is and what a domain structure is. Now let's talk about access matrix. Now access matrix is basically, when we talk about permissions, we normally talk about what access to be given to that particular domain, right? So I'll show you that with an example. So in order to understand the access matrix, what we do is we normally, now since it looks like a matrix, rows and columns, that's why we call it an access matrix. Normally when you are designing your protection policies or permission policies, if you are a security head at an organization, we normally use these on a paper or maybe in Excel to understand which user should be given which type of permissions on each folder, each directory, or a domain itself, right? So we have some objects. Let's assume we have some objects. Then we have on the rows we have domains, and on the columns we have files, right? And resources we call them. So there are some files and there is a printer as well, right? Now in domain 1, if we are talking about only one object, maybe O1, then O1 has, if O1 is in directory 1, it has read access to file 1 and read access to file 3. It has no access to file 2, it has no access to the printer as well. Similarly, if object 1 is in domain number 2, it has no access to any files, but it can still print. I don't know what it's going to print, but it can still access the printer, right? Similarly, object 1 has access to domain 3. When it's in domain 3, it does not have access to file 1, it does not have access to the printer, but it has read access to file 2 and execute access to file 3. Similarly, in domain 4, it has read and write access to file 1, it has no access to file 2, read and write access to file 3, and has no access to printer. This is normally how we design our access matrix, including domains, objects, and the resources, right? I mean, you can do files, you can do resources on the rows, but normally the traditional way of doing it is to have domains on the rows side and resources on the column side, right? I hope you can now read what this slide is saying. Now obviously, I mean, if it's an object, it can still switch between different domains, and it can switch between permissions as well. So what I mean by that is an object can switch from one domain to another domain, right? Now for example, if we say again object 1, so we have domains over here, we have resources over here up till here, right? And we have an object, for example O1. So we have an object. Now that can be a user, that can be anybody, right? Let's talk in general. Let's call this an object. So O1 is in domain 1, which means that object in domain 1 can only read file 1, cannot do anything with file 2, can read file 3, and cannot do anything with laser printer. But if you see the next part of this matrix, what it does is it is containing the same number of domains as here, as columns as well, right? What it says is that if object 1 is in domain 1, object 1 can switch to domain 2 as well. No worries. So object 1 can switch to domain 2 if it wants. It is allowed to switch between domain 1 and domain 2. So if an object is in domain 1, it can work with things in domain 2. So it can switch to domain 2. It has been given permission to switch to domain 2 as well, right? Now if an object is in domain 2 and it has no access to files but has access to printer, it can switch to domain 3 and domain 4. So it can switch to, so if it wants to, so if object 1 wants to access file 1 and currently it's in domain 2, it does not have access to file 1, right? What it has to do, it has to switch to domain 4 so that it can have read and write access to file 1, and so on and so forth with the other one. So normally when we talk about switching between domains, we design a matrix like this so that we can over here tell the object can switch between domains. Now if object is in domain 3, for example, it cannot switch to anything, right? Which means that it will have no access to file 1 ever, it will have no access to printer ever, but it has read access to file 2 and execute access to file 3, but it cannot have access to other things. Similarly, as I just told you, if something is in different domain, it want to access a different file, then it can switch between domains to access that files, right? So this is called access matrix. Next thing that comes is the access control. Now protection, as I mentioned earlier, can be applied to non-file resources as well. So your access control, so your read control, your write control, or your execution control not necessarily have to be on file. They can be on printer, can be on any other resource. Well, Linux calls everything a file, but it can be any other resources as well, right? So now Solaris 10 actually provides role-based access control to implement the least privilege. We already talked about least privileges. And what normally happens is if you want to give a least privileges, what you have to do is you have to make sure that at least that whoever you are giving the least privileges, for example, there is a process P1, if you are giving it a least privileges, you have to give that process at least the privileges to run, right? If this process is not able to execute, then it's there for nothing, right? So that's why these access controls and access matrices and protections are pretty important, that your resources or your processes should not keep on hanging there because they cannot do anything. Then why we have created them? If there is a solid reason behind creating this and not allowing it to execute, then it's fine. But if it's going to execute based on some permission, then it's okay, it's fine. But if it's going to stay there and never execute, then there is no use of that, right? So normally access control is all about roles. What roles are you, what role an object can perform. That role can be executing something, reading something, or writing something. Now what I want to do is, in order to further explain this access control, I'm going to explain it to you the Linux permissions, because they are pretty good example of how access controls normally work. Now in Linux we normally have permissions for all the resources. So if you want to access a file as a user, you have permissions for that, or you might not have permissions for that. And those permissions are normally 4 types of permissions in Linux. There is a read permission, there is a write permission, there is an execute permission, and there is no permission, right? So these are 4 types of permissions or rules or access that is given in Linux, right? So if you want to read a file, you need to have a read access. If you want to write on a file, I'm just giving you an example of file, it can be directory, it can be anything, right? So if you want to write on a file, you need to have write access to that file. If you want to execute a file, you need to have execute permissions on that. If there is no permission, then you might not be able to do any of these things, right? So these are the 4 types of permissions. Now these permissions are applied on 3 things. Permissions are applied for owner, permissions are applied for group, and permissions are applied for everyone. I'm going to explain that permission to you in a while. Now when we do something like this, what I'm going to do is I'm going to switch to my Ubuntu and explain it to you over there. So let's do this. What I want to do over here is what I want to do is I want to create a file over here. So let me create a file and put something inside that file. So let me maybe move to desktop. So let me create a file over here. Let me call it hello, and let me call that file hello.txt as well. So if I do this, I've just created a file. If I see what is inside that file, I can just see by doing this. So there is hello inside this file. Now if I want to see what permissions this file has, I can do something like this, right? So when I do ls-la, what it does is it starts showing me the permission. So I'm going to talk about these permissions. So what's going on over here is, what I want to do is I want to create a directory as well. So mkdir, and I'm going to call it test. So I've created a directory as well. Let me do ls-la as well. So let me talk about these two now. What are different permissions for a file and for a directory? Now if you see, let me talk about directory first. If you see, these are actually the permissions. So these are the permissions. They are in a set of 3. So this is a separate thing, and then we have a set of 3 for this. This is a permission, this is a this is a permission, and then we have this permission. I'll go to slides and show you that in a while as well, but let's have a look in detail what these permissions actually look like, right? So what is happening over here is, let me okay, let's keep it like this for now. Okay, so D over here means it's a directory or a file. So if it's a directory, it will say D over here. If it's a file, it will have nothing over here. As you can see, for hello.txt, since it's a file, there is nothing here. Now if I talk about next 3 things, so they are in set of 3 after that. So read, write, and dash. If I see this one, it says read, write, execute. So on this folder, I have, so this is the user and this is the group. So I as a user have read, write, and execute permissions on this folder, right? These 3 permissions actually, like this, right? Similarly, the group I am part of, so every user is a part of a group in Linux, right? So each user will fall in a group of users, right? I am part of Raziqbal group as well, and the name of my username is also Raziqbal. So similarly, there might be a group of students, and all the students might be part of that group. Similarly, there can be a group of faculty, and all the faculty members can be a group of can be part of that. All the usernames of the faculty members will be part of that group as well. So over here, the group name and my username, they are same, right? Okay, so this first set of 3 permissions, read, write, and execute, as we said that there are only 4 permissions. Either it's a read, write, execute, or no permission. Over here we have 3 permissions. So I as a user can read on this one. I am the owner. So this first set of permission is for the owner of this file. Who's the owner of the file? I am the owner of the file, right? I have read, write, and execute permissions on that. Excellent. Now the next 3 permissions are, these next 3 permissions are for anybody that falls in that group. So these 3 permissions are for the group. So the name of my group is Raziqbal. So any user that is part of this group Raziqbal has access to, has read, write, and execute permissions on this folder. All right. So first one is for the owner. First set of permission is for the owner, whoever is the owner of this file. Second set of permission is for anybody that falls in this group. So there might be other users in this group. They all will have this permission for this directory, right? Read, write, and execute. Next set of permission is for everybody else. So anybody that is not the owner, or anybody that is not part of this group, will have write and execute permission. They don't have write permissions on this folder. So there might be other groups as well. There might be other users as well that are not part of this group and that are not this user. They will have read. They can still read this directory. They can still execute this directory, but they cannot write on this directory, right? So this is how permissions actually work. If you see this file now, you can see that file, since it's a file, it will not say anything over here in the first flag. So normally for directory it's a D for directory. If it's a dash, then it means it's a file. Then if you see the next 3 set of permissions, which is R, W, and X, since it's a text file, I'm not going to execute this file, right? So I can read on this file, read from this file, or I can write on this file, right? So the first set of permission is read, write. That is for whom? For the owner. Who is the owner? I am the owner, right? So I have read permissions on this, write permissions on this, and for execute I have no permissions because I cannot execute this file. It's not an executable file, right? It's a text file. next permission is for the group, which is this group, right? Anybody falling in this group will have these set of permissions, R, W and X, R, W and dash, there is no X. So anybody that is part of this group, any user that is part of this group will have read, write permissions on this, and obviously they cannot execute this file since it's not an executable file. Next set is for everybody else that is not this user or does not fall in this group. They can still read this file, but they cannot write on this file. I'm talking about this hello.txt, right? Hello.txt. This is how your permissions work, right? So if I go back, this is exactly what I'm telling you over here. So this is how the permissions look like. First thing is for file or directory. Second set of permissions is for the owner. Whoever is the owner of the file, these permissions, they belong to that owner. Second set of permissions is a group permission. So this was my group. Anybody that falls in this group will have read, write and execute permissions. And last one is for others or everybody else that is not part of this group and that is not this user. They will have these permissions, right? Now normally Linux permissions, they work like this. So I just told you there are set of three. There are set of three, right? So there is an owner permission, there is a group permission, and there is everybody else or others permission, right? And there are only three permissions. The fourth permission, dash, means there is no permission, right? But normally if there are permissions, there is either read, write or execute. Now how does this work? What does this mean? You might have seen on internet they are telling you numbers like 700 or 4655, for example. Where are these numbers coming from? What these permissions actually mean? So I'm going to explain it to you now, so that you actually get an idea of where these numbers are coming from. And if I want to give read, write and execute permissions to any file or folder, how can I do that? And I'm going to run an example for you as well, but let me first explain what they are and how they actually work. Some of you might already know this, so you can skip this part and you can move directly to the other part. But students who have no idea what these actually are or who are confused about this permission, I think it's a good time to understand this. All right. Okay. So if I want to give a permission to a file or a directory, I will do either a 0 or a 1, right? If I want to give a permission, I will make that flag equal to 1. If I want to give no permission on that, I will make that flag equal to 0. So if I put 1, 1 and 1 here, it means that I'm giving this guy, whoever this guy is, maybe user 1 or whatever, I'm giving this guy the permission to read, to write and to execute, right? Because I'm saying 1, 1 and 1. Now if I want to give another user, or maybe another user 2 for example, I want to give this guy only the read and write permissions, I will do 1, 1 and 0. Now this guy will have read permission, write permission, but no execute permission. There is another user 3 for example, and I'm talking about the owner, right? The owner of the file, right? I'm assuming that this guy is the owner of the file. So if I want to give this owner the permissions to only read this file, what I can do is I will do 1 and 0 and 0, which means that this guy can only read the file, cannot write on that file, cannot execute that file, right? And I'm assuming that it's an executable file. I'm not assuming a text file. Similarly, there is another user 4 and he's the owner, and I'm giving this guy only the write permission. So I will do 0, 1 and 0. So this guy can only write on this, right? Similarly, another user comes and I will give this guy only executable permission. So I will do 0, 0 and 1, right? Or I can give maybe write and executable permission. So I will do 0, 1 and 1. This guy can write, can read, can execute, right? Based on these permissions. Now I hope you guys understand this. So this is how permissions are actually done, right? So I can give anybody any permission if I am the owner, right? And I'm talking about only the owner. I will talk about the group permissions as well in a while. So this is how we normally do it, right? So I want to give this owner the write permission, read permission and execute permission. This is this. Now how do I end up getting these numbers then, right? How do I end up getting these numbers? I will come to these numbers in a while. Let me talk about group permissions now. All right. So let's assume that there is this user and there is a group, maybe let's call it G1. Now anybody that is part of this group, I want to give it all the permissions, right? They can read, they can write and they can execute. Maybe there is another group, I want to give them read permission. I don't want to give them write permission. I want to give them execute permissions, right? So another group, maybe G3, this group, I want to give them only the write permission, so I can do this, right? Similarly, G4, I want to give them only the executable permission, so I can do something like this, right? So this is something I can do. Similarly, anybody that is not part of this group, so I want to set the last set of permission as well. So anybody that is other, for example, let me call it other. So anybody that is not part of this group, I want to give them, or is not this user, I want to give them some permission. So maybe I want to give them only executable permissions, right? Or I want to give them only the write permissions, or I want to give them only the read permissions, right? Or I want to give them read and write permissions, no execute permissions, or I want to give them read and execute permissions, no write permissions, right? So this is how we can set permission. And I will show you the commands how you can set permissions, but this is the general idea behind permissions. Now let's talk about these numbers, how these numbers come into being. Now these are all binary numbers. If you see, they are either zeros or ones. 777, if I convert this from binary to decimal, this is 7, right? 110, if I convert this into decimal, it's 6. Similarly, 100 is 4. 010 is 2, 001 is 1, 011 is 3, right? Similarly, this is 7, this is 5, this is 2, this is 1, right? Similarly, this one in decimal, if I convert them into decimal, this is 1, this is 2, this is 4, this is 6, this is 5, right? So if I'm talking about the first type of first permission only, so if I'm talking about this set of permission which I just gave, for example, I can combine them all permissions and I can make a number like this, right? Which means that this is 7, 7 and 1, 7, 7 and 1, 7 from here, 7 from here, 1 from here, which means that the owner of this file has read, write and execute permissions on this file, whatever this file is. The group has read, write and execute permissions on that, which is 7 again, so I have 2 7s, and anybody else who is not this user 1 or who is not part of this group has only executable permission, so I put just 1 over here, right? Similarly, let's maybe talk about this now. Let's talk about this one. So in this case, what I have, the permissions I have is this guy, this user who is the owner of this file has only the read permissions on it. The group has 2 over here, so group has 0 1 0 over here, and everybody else has only read permissions on it, so I end up getting this permission, right? Now this is how the permissions actually work, and I hope it is clear to you now how we are actually coming up with these numbers, and this is how we come up with these numbers. There are other ways of doing it as well, and I'm going to show you one example for that as well, but if you know how this actually works, you can do everything in Linux as far as permissions are concerned, right? So if, for example, I want to make sure that there is a file, so for example there is a file, file 1, and I want to make sure that this file belongs to only user 1, all right, only user 1, so that user has all the 3 permissions, read, write and execute, and since this user belongs to a group G1, should have no permissions, so nobody in this group should be able to read, write or access read, write or execute this file. And similarly, anybody else which is not this user or does not fall in this group should also not be able to read, write or execute this. What I end up getting this for this file, I end up getting 700. This is the permission, right? Which means that only the user can read, write and access this file, read, write and execute this file. Nobody else can do that, right? So we can make this file, this permission, right? So this is how actually our permissions work. And if I talk about Linux, these are the commands. If you want to change permission, you normally use chmod, right? Chmod. This is the command that is used for changing the permission in Linux. If you want to change the ownership of a file, if you remember, this is the ownership. If you want to, for example, user 1 is here. If you want to make user 2 the owner of this file, we normally use this command chown, right? So this is how permissions work. What I'm going to do is I'm going to go to my Linux now and work on assigning the permissions. So I have a file over here. For this one, these are the permissions I have. So this user is this user is actually the owner of this file. This is the group where this user belongs to. and everybody else on this one has no permissions, right? So if I want to give a permission of 700 here, which means that only the user will have access to this file. No, I cannot do 700 because text file is not executable file. Let's talk about maybe this directory, right? Let's talk about this directory. So what I can do is, since I want to change this permission to 700, I have to do sudo chmod. This is the command I use. I'll do 700 and then I'm gonna do test the resource that I want to change permissions for, right? So I want to change permissions for this test folder, and I have to be in that directory, and this is the directory I am in, and I want to change this permission to 700, which means that only the owner of this file should have read, write and execute permission. Everybody should have no access to this file. No read, no write, no execute, right? So if I press an enter over here and I do ls-la again, you can now see that the permissions were this. Now the permissions are this one, which means that owner has all the three permissions, which is 1 1 1, which makes it 7, and all the other permissions were 0. So this set is 0, which is this set over here, and this last set is 0, which is this set. So I have successfully changed the permissions of this one, right? Similarly, I can change permissions for a file as well, like over here. So for example, I want to make permissions in such a way that the group should only be able to read this file, don't write that file. So what I do normally, what I have to do over here is, this permission will be 1 1 0, which is 6, and I make 1 0 0, which is 4, and 1 0 0, which is 4. So it will be 6 4 4. So if I change permissions on that, I will do 6 4 4, and I want to change permissions for hello file. I will do something like this, and if I do ls-la again, my permissions are this, which were this. So the owner can read and write, but others can only read on this file. I can give other permissions as well, just like what I did over here. So I can change these permissions any way I like, but I should have access to that file. I should have permissions to change permissions. If I don't have it, then I won't be able to do it, right? So this is how you change permission. Well, there is another way to do that as well. So for example, if I want to if these numbers are not making sense to me, which I think are much easier, as long as you understand the concept I just explained you in the previous slide, then these numbers are pretty easy to translate these permissions into. But if you think they are not easy, what you can do is you can still use the other things. So for example, if I want to change this permission back to read write dash read write, or since you already know about read write, what I can do is I want to add let's talk about this one, since I want to work on this one. So what I can do is I want to remove the execute permissions from here. So what I do is I can do chmod. I will do the execute permissions. I will remove the execute permissions from here, and I will do something like this. So it's I think it's u minus x, if I'm not wrong. Oops. U minus x, so which is user, and I want to remove from this user the executable permissions, right? So if I do ls-la, you can see that from these permissions I have removed from the user the executable permissions, right? So I can do this as well. I can work like this as well, where x is the executable permission and I'm just subtracting that x from this. I can add the x permission as well. So I can, if I want to bring that back, I can do u plus x, and if I do ls-la again, I again have the executable permissions, right? Similarly, if you want to put read permissions, for example, for the group without using numbers, you can do group, which is G for group, and you want to add maybe the read permissions on this, you can do something like this. So I now have the read permissions for the group, and I have permissions for my user as well, and for others you can do O plus and so on. Whatever way makes more sense to you, you can use that way. If you think you are more comfortable with these numbers, then go ahead, do with these numbers. If you think you are comfortable with this type of pattern, you can do it that way. It's totally up to you how you want to use it, right? So this is how permissions actually work. One last thing is about the ownership. So what I want to do now is for ls, for hello.txt, I have these permissions. I want to change. So right now the owner, I am the owner of this file. I want to change this ownership to the root, right? So I want to give root the ownership of this file. So in that case, what I can do is I can use the command chown root : root. It's always a good idea. Root : root means root, which is the username, and he belongs to the root group, right? So I want to give root the ownership of this file. Ownership of what? Ownership of this file. Oops. Hello.txt. If I do this, if I do ls-la again, you can now see this ownership of this file was something like this, and now the ownership of this file is given to the root. Now root has ownership to this file, right? Similarly, I can give access to root to this, or what I can do is maybe I can just let me change this to root as well. So maybe I want to give access to, I want to give ownership of this folder to root as well. So if I do something like this, and I do ls-la, you can see I can do something like this, right? So root has access to this, nobody else has access to this, right? So you can change the ownership as well like this, and you can check the permissions from here. You can also go and check the permissions from here as well in GUI if you want to see. So you can see the root is the owner, and group is also root, and access list files only, so they have only list file access and they have no access at all. So if I double click this, it will say that this location could not be displayed because I do not have access, only root has access to this. And if I try to open this file, it will still show me because maybe I have read access for everybody else. So if you see for hello, everybody else, anybody that is part of this group has root access, anybody that is not part of the group, anybody else except root, or anybody that is not part of the root group, they still have the root access. You can always change that. So try to work it yourself, try to work on these permissions, and you will see that permissions are not that difficult. Normally students are quite confused about these permissions. I've seen a lot of students not grasping the idea of these permissions. I hope you guys are now clear with these permissions, how they actually work, what are these permissions, why do we use these permissions, and how do we change the ownership and permissions for the files and the folders. And same you can do with the resources as well. So that's how permissions work, right? So I hope you guys are clear on permissions. What I'm going to do is I'm going to move next. So we have been talking about protection for now, and we have talked about Linux permissions. Let's move to the next topic, which is a security topic, operating system security. Now, operating system is considered to be secure if it is accessed in an intended way, right? So if only user 1 has access to the system, then that means that that system is secure, right? If user 1 has access to the system, but some attacker A1 also gains access to the system, it means that that system is not secure. This is the whole idea of security, right? Now, intruders, we call them crackers as well, they try to breach the security, so they might want to break into your system because of so many reasons. Threat is actually a technical word, that is the potential security violation. If somebody is violating the security, which is happening in this case, this is called a threat, right? Now, attack is again the attempt to breach your security. If somebody is trying to attack it, then this attack is actually called an attack. Now, this attack can be accidental, it can be malicious. If this guy is intentionally doing it, it means that this is malicious. If it's accidental for some reason, these are called accidental, right? Now, security violations, there can be several security violations. They have been divided into few types. Now, breach of confidentiality, that means that somebody who has no access to the data, who should not be authorized to read a data, is actually reading that data, right? So for example, user 1 has access to file 1, which is fine, but user 2 does not have access to this file, but he's still using it, which means that this is not okay. This is called breach of confidentiality, right? For example, if in an organization, HR employees, they have a file called salaries. If they have a file salaries dot maybe Excel file, if they have a salaries file, and anybody that is in department, they have access to the salaries file. Anybody else, if an employee E1 starts having access to the salaries file, this is breach of confidentiality. This guy has no right to access this, right? So this is called breach of confidentiality, which means that unauthorized person are also trying to read data, right? Breach of integrity. Again, let's take the same example. For example, if somebody is given salary based on this file, so every month an HR guy looks at this salary and transfers the salary to people's account. This one guy, employee 1, he comes in, he goes and increases his salary by 1,000 like this. This is called breach of integrity, because he went over there. Reading only is fine, which is breach of confidentiality, but modifying that, reading that file and then modifying that data is called a breach of integrity. If you are modifying that file, it's called breach of integrity, right? Now, breach of unavailability. Breach of unavailability actually mean unauthorized destruction of data. For example, again, let's talk about this file. So there is salary.xls and all the employees. So for example, there are members of this department, M1, M2 and M3. There are three people in HR, and they all have access to salary file, right? Now, for some reason, M3 has left the organization, and before leaving the organization, he went and deleted this file. Then these two guys, M1 and M2, who are still part of this department, part of this company, they have no access to this file. This is called breach of availability, right? Which means that this file should be available, but for some reason this is not now available because somebody has just destroyed that file, destroyed that data and unauthorized it, because this guy was not part of this organization anymore, and before leaving he actually deleted this file, right? Theft of service, unauthorized use of resource. Now this is pretty common these days because of the cloud, because of cloud resources. So we have cloud computing. On cloud you can have a lot of resources, so a lot of companies are using the CPUs, the hard drive in the cloud, right? So you might be using Dropbox or Google Drive or OneDrive. So what they are doing is they are giving you hard disk space on their cloud, and you can save your data over there, and you can go anywhere in the world and can still use that data. So some people now, what they do is they try to steal this information, steal these resources. So for example, a user U1 has a quota of only 15 GB. These days even 15 GB is only, because we have a lot of data generation. So user 1 has 15 GB of data, but and he's almost done with his 15 GB of quota. He needs more space. So what he does is, so there is another user U2, he has 15 GB as well. What this user does is he goes and does some manipulation and steals the free space of this data, this user as well. So his space is now 20 GB for some reason. I'm just giving you a very lame example, but this is what is called unauthorized use of resources. And this guy is left with 10 GB of data now. So this is stealing of resources. You are stealing the resources by stealing the hard drive space, right? So this is called theft of service. Then denial of service means prevention of legitimate use. It's pretty similar to what we have over here is, but this domain is pretty broad. It's not only breach of availability. This domain is pretty broad. We call it denial of service, and then there is another part of it which is called distributed denial of services, which means that, for example, you have Gmail, you have an account on Gmail, so there is a Gmail server that is holding your inboxes or emails of a lot of people. A hacker or an intruder or a cracker, he comes, what he does is he sends a lot of emails to the server so that the server actually goes down, right? He sends so many requests to Gmail that this server for some reason goes down, and all the people who are having access to Gmail, they have their account on Gmail, they are not able to access this server now. They are legitimate users, but they are not able to access this Gmail now because the server went down, because of somebody came and sent so many things to the server, and this server was not able to accept that many requests, and it went down. This is called denial of service, right? I hope you guys are now clear about this. These topics are discussed in a lot more detail in network security courses, so that's why I'm not going into a detail of these things, because this actually is part of that course. So in this course I just have to give you a brief idea of what they are and how they are related to operating system. Now there are different security violation methods. We have discussed about what type of security violations are there. Now, there are different methods of security violations. Masquerading or breach authentication is one of them, which means that user 1 has access to the system, for example, and user 2 is a guest, for example. So for example, this is a standard user, right, and this is a guest user. And obviously standard users can install software on it, can do a lot of things with the system, but guest users, they have very limited access to the system, right? They cannot install software or whatever. This user, what it does is for some reason he hacked the system, and this user gave itself from the guest user the access to the standard user. So now this user U2 has access to install things on the system, do whatever user 2 can do. This is called masquerading, by increasing your privileges from whatever you have right now to improved or enhanced or escalated privileges. This is called breach authentication or masquerading. Now the other one is a replay attack. A replay attack is normally done with the message modifications. It normally happens when you are sending messages and you are modifying the messages. So for example, there is a user 1 and there is user 2, and they are communicating with each other through messages or whatever communication medium is. There is an attacker over here. Then attacker comes, and whenever user 1 is sending messages to user 2, it's just hijacking those messages and adding something to that message. These are called replay attacks. And I mean, these attacks can be any type of attack, but I just gave you a very simple example. There are so many different examples of replay attacks also. Then man in the middle, just what I told you right now. A man in the middle will come and maybe not changing this message, but start listening to what they are saying, and just seeing what they are communicating about each other. So it's just a breach of information. It's just sitting there and reading or getting the information about this, right? Then session hijacking. What session hijacking means is, for example, user 1 has signed into Gmail, and now Gmail will keep logged in for some time. Maybe let's assume when you sign into Gmail, it signs in for 15 seconds, right? Now this session has been created, and this session will stay active for 15 minutes. This session will remain active for 15 minutes. So you don't have to sign into Gmail again for 15 minutes, right? But if you remain inactive at Gmail, it might sign you out and you have to sign in again. So what session hijacking means is, when your session is built, an attacker will come and attacker will hijack this session, which means that this attacker now has your username and passwords, or not have username and password, but this user has access to your session, which actually is allowing you to access your Gmail. So you don't have to sign in. So this attacker, if this attacker has access to your session, this attacker does not need to sign into your inbox now, because that session has already signed in for 15 minutes, right? So this is called session hijacking. I just showed you now what these are. So these are just the examples which I just told you. Now security measure levels, there are different security measure levels also. So majorly there are 4 of them. So first security measure is the physical one. So physically you need to make sure that your servers or your data centers or your terminals or your systems in general, they are physically secure. So you have them in the locked doors, you have them secured physically, you have locks over there, you have enough security over there, maybe security guards outside your server if it's containing the sensitive data and so on. The physical protection is at the highest level. So if everything is done but there is no physical security for you, then someone can come and destroy your data centers, right? And you will have no access to your data. So physical security is at the highest level of the security. Then human security, very important. What it does is, for example, if you have physical security and only few people they have access to your, for example, there is user 1 that has access to your servers, and maybe there are a couple of other users that have access to your servers. Now what these users do is they are signing in to your server, into this server using their smart devices, and they left their smart device on the table and went to washroom, for example. Anybody in the bar, for example, if this guy is sitting in the bar, this guy comes and sees what's going on in the server, then this human is responsible for this breach, right? Because it's very, very important at our level, at human level, that we secure that information. This is just one example. It can be several examples. So phishing attack, for example, this user has a computer C1, and this computer has access to this server, for example, and this computer gets compromised because of this user. For example, this user has clicked a spam email or a phishing attack or anything, and because of that this computer got compromised. And because this computer got compromised, this computer now, since it already has an access to server, this server now gets compromised. So humans are an important and very, very crucial factor when it comes to security measures. Then operating systems. Operating systems are pretty responsible for your security measures. For example, if on this server there is an operating system running, maybe Linux or whatever operating system is running, and this operating system crashes for some reason, and because of that crash the hackers were able to enter the system. We normally call it buffer overflows. This is one of the ways. So you might have noticed, I'm not into news these days with Apple, but when Apple iPhone came, since it was not open to all the providers, hackers from throughout the world, they actually created jailbreak. I'm sure a lot of you already know this terminology. So what jailbreak does is basically it hacks your operating system. So that utility actually goes and see vulnerability in your operating system. They try to make your operating system crash, and when operating system crashes, they actually give operating system the address to the new memory location, right? New memory location in the RAM, and at that memory location there is a program sitting, and that program actually starts executing instead of your operating system. And then operating system doesn't know that there is a program, because operating system actually crashed. A lot of services that are actually checking RAM for operating system for security, they actually crashed, and now your program is in charge of operating system. So jailbreak actually used to work like this. I don't know anymore how it works, because I'm not following up with the news too much, but this is how your operating system can be compromised, and this is how your security measure levels can actually be compromised using operating system. Then network, very common attacks we have in network. So for example, you have your Wi-Fi, and that Wi-Fi somehow gets compromised because of some attacker. So at your Wi-Fi at home, you might have your smart devices, you might have your computer, you might have your smart TV attached. So when attacker compromises your Wi-Fi and enters your Wi-Fi or your home network, attacker has access to all of these things, right? So network, another important factor when it comes to security measure levels. Program threats, I'm going to quickly go through them because some of them you might already know. Some of the program threats that are very common when it comes to security in operating system is Trojan horse. What it does is it basically is a code segment that misuses its environment. So now that misuse can be anything. It can be a program that actually runs some part of the program fine, but that at some part of its program it runs something which it is not authorized to do, right? But it does that because it has already been installed on the system, and now it can do whatever it likes because it has been a part of that operating system for quite some time, right? Now these can be your spywares, they can be your pop-up browsers, they can be covert channels and so on. I'm not going to go into a lot of details because we already know what Trojan horses are. And then there is a trapdoor. Trapdoor means a specific user password actually breaches your security. Now what happens is, what normally trapdoor does is, for example, you have created, normally a lot of software developers, what they do is they keep a backdoor actually. So they have created a software like this. So they keep a backdoor. So for example, if something is not working, if an operating system has crashed or your program has crashed, they actually keep a backdoor to enter to that software to debug it, right? Now if that backdoor is being somebody knows about that backdoor except the software developer, then that attacker can go and use that backdoor to enter your software, and then from there it can enter your operating system, and from operating system it can compromise your whole system, right? So that is called a trapdoor actually. And now they are very difficult to detect, because in order to detect them you have to go through all the lines of codes, right, unless you find that backdoor. Now this is what normally happens with a lot of applications on smartphone these days. That's why Apple is pretty strict when it comes to installing applications on your Apple devices. They actually go through App Store, they review their code, they review their functionality, and then they let them on app stores. Even Android Play Store now has very strict policies when it comes to installing apps on your devices, because a lot of things have already happened in past, because an application what they actually are intended to do, they were not doing that, they were doing something else. They were retrieving the data of users and sending them to different servers throughout the world. So these are called trapdoors. Logic bomb, we know this. It's a program that actually initiates an incident in certain circumstances. Now, for example, if there is an employee E1 working for a company, and maybe this guy is a software developer. So this guy has developed this software which is running in this company to maybe calculate the payrolls or whatever, right? So for example, if this company has fired that employee, and that employee has actually, since this software developer developed this program, what he does is the program will check if this guy is still employed or not, if this guy is still on the payroll or not. If this guy is not on payroll, which means that this guy has been kicked out of the company, this program will start doing something. It will check the condition that this employee is still part of the company or not. If this guy is still part of the company, run it properly, no problem. If this guy is not part of this company, maybe crash the software, right? So this is called a logic bomb. So I don't know, people do this. The other thing is stack and buffer overflow. I just told you, and I gave you an example of jailbreak. So this is exactly what I was talking about. So you start getting unauthorized user privileges, and you give escalation to the user. So basically what jailbreak does is it gives root access to one of the store, which is I think called CDI, if I'm not wrong. It used to call CDI, I don't know what it's called now. So it gives CDI the root access to your system, and any application you are installing through CDI, it gets the root access, right? So if all the programs on operating system gets root access, then it can crash. It has a lot of chances to crash. Now CDI, I think after the first version, it started giving very selective permissions to the applications, but at least CDI had root access, which can install everything on your system, right? So this is Stack Overflow, and this is how normally CDI works, using Stack Overflow. Then we have viruses. I'm not going to go into the detail of viruses. We all know what viruses. They are legitimate programs, but they are embedded into some other programs that can do anything. So for example, this is one VB program. What it does is it can just format your drive, right? It can just reformat your drive, and maybe if this code is part of some other program, and with this few lines of code, it can just reformat your hard drive, so you lose all of your data. So this can be a virus. So a virus means it will go to your computer, it will just do something to your computer which was not intended, right? We all know this. Computer viruses, we are very aware of these. Attacks are pretty common, and attacks are happening over time. And why Windows was the major major operating system to be attacked? Because security was not too high in Windows because of the user accounts and permissions and so on. Linux or any Unix based system, they are pretty strict when it comes to permissions and so on. That's why they had no attacks, at least very few attacks. But Windows, since it was not account based and so on, so there were so many attacks on Windows. And the other reason is Windows was the most common operating system, so we have seen a lot of attacks on Windows, right? Then we have network attacks. Attacks, we already talked about network attacks. And since you are using network, and if you're part of a bigger network which is internet, then you have more chances of getting compromised, right? Because if you have access to a lot of other people, you have more chances to get compromised, right? That's why it's very important to don't share your information when you are internet. Don't share your information, credit card or other information or personal information on the website that you don't trust, right? So because once you are done, attacker can enter your operating system by giving legitimate information, because then he or she has your username or passwords or your personal detail and can enter your system, and operating system would not know if it's you or no, right? So that's why network threats are becoming pretty common these days. Worms are one of them. I'm not going into the detail, I've just included the details for you, just to see what they actually mean, but I will not go into the detail because these are more part of the networking course and the security course, right? Port scanning is pretty important. Sometimes what it happens is we have different ports, right? Ports are basically the doors to your operating system, doors to your system. For example, 80 is the port that is used for browsing. I think 22 port is normally used for file TCP, sorry, FTP, if I'm not wrong, right? Similarly, these are the ports that are used to do different things. So if you want to browse, you use this port. If you want to transfer file, you use 22 port. It's just like having different doors in your room or in your house. There is a back door to your house which opens maybe in your backyard. There is a front door that opens to the front door. There is a garage door maybe that opens from the garage. These are different doors that have access to your computer. So these are the ports that give access to different programs on your computer. And port scanning, what port scanning software do normally is they actually look at which ports are open. So if this port is not open, I won't be able to access internet. If this port is not open, I won't be able to access my file transfer files, right? Similarly, if a door to your house is not open, you cannot enter, right? So these are just the same thing. So port scanning software, what they do is they run on your computer and they tell you what ports are open, right? Which ports are open. And Nmap is a pretty famous program that runs on Linux to tell which ports are open. Let me quickly show it to you how it actually works. So you might not have it installed on your system, Nmap. So for that you need to install it. Sorry, I need to do info. Okay, let's see. I have information like this. Okay, so this is what it does, Nmap. So if it's installed, it will show you the version of that software, and you can just see what ports are open. So maybe I can just Nmap and I can provide the IP address, and I think it's 12, and it will, this is the IP address of my current computer, and it can show me which ports are open. So currently for me this TCP port is open for SSH. So if I want to SSH into my computer, I can use this port and it's open, you can see over here. Similarly, if I want to do Nmap on my router, it might take some time because it will check all the ports and then tell us which ports are open. So on my router I have more ports open. You can see over here there are 993 ports that are closed, and these 7 ports are open. So for SSH it's open, HTTP is open, HTTPS is open, and these are how it works. I actually have my Fedora open over here as well. What I can do over here is I can check my Fedora as well. So I have 2 virtual boxes running for me. So for one I have Fedora running and the other one I have Ubuntu running. So I can check my Fedora device to see which ports are open for my Fedora, if I'm not wrong. 22, yeah. It doesn't have anything open, I don't know. So I mean, you can check on your system which ports are open, which ports are not open. You can check like that. And this is port scanning. So what hackers normally do is they normally see which ports are open, which doors are open, and they try to enter those doors from enter your system through those doors, right? So it's very important that you keep only the ports open that are required. Keep all the other ports closed, right? Denial of service I already told you, and I already told you what denial of service is. Basically, if something goes down, it should be available, but it's not now available, and it's denying the service, right? And I gave you an example of Gmail. So denial of service is also part of the network threats. Then comes cryptography. Cryptography is pretty in these days. It's available almost everywhere. In at least on our network, cryptography techniques are there. What we normally do is I have a diagram for this. Okay. So what we do normally in cryptography is we have a plain text. So if I want to transfer a text file to my friend, so if Alice wants to transfer this text file to Bob, what encryption does is normally what cryptography does is it will encrypt this file with a key, right? That key can be anything. So for example, if I have A, B, C written in my text file, this key will encrypt using the encryption algorithm. So this key might be take the ASCII, this key can be anything, divided by 10, this can be key or add 10 to it or whatever, right? So this is maybe 65 in ASCII, this is 66 in ASCII, this is 69 in ASCII. Using this key, what I can do is I can just add 10 to it. So this becomes 75, this becomes 76, this becomes 60, 79, and then this basically encryption, this is the encryption algorithm that is using this key to generate this new text. So this actual text is now encrypted. I now have, instead of ABC, I have, I don't know, whatever this is, maybe J, K, L, I don't know. This text is now encrypted into this one. So even if this guy Trudy, this guy gets this cipher text, get this encrypted text, this guy will not know what this actually means, right? Because it's an encryption form. This text in encryption form is also called a cipher text, right? And when Bob takes it, Bob uses his key, which is the same key as this one, and it will be decrypted back to the original text, and he or she can read that, right? So this is called cryptography. And cryptography normally has 4 parts. It has an encryption algorithm that is used to encrypt the data. It has decryption algorithm, which is used to decrypt the data. It has cipher text, which is actually the encrypted text, and then it has a key that is provided to encrypt and decrypt data, right? I just gave you an example. Now there are 2 major techniques of cryptography. Again, I am not going into the detail of cryptography. It's a very broad topic. In fact, I studied a cryptography course in my bachelor's that was a whole course on cryptography, right? So it's a very broad topic, and I'm not going into the detail of this topic. I'm just giving you a broad idea of what cryptography is. So cryptography has 2 techniques. It has a symmetric key encryption, which means that the keys are identical, which means that the keys for encryption and keys for decryption, they are both identical. And there is a public key encryption. It uses 2 keys. One key is unknown and one key is known. So one key is for encryption and the other key is for decryption. One key is known and the other key is unknown. We can normally call them private and public keys as well. So what symmetric key does is, I just told you about, this is all about symmetric cryptography, right? So there is a key which is same for Alice and Bob, and it can be decrypted. For asymmetric, it's normally called public key encryption, and it uses 2 keys, public key and private key. If I have an example over here, I don't have it. So what normally it does is, if I go back to this example, it uses a different key for encryption and it uses a different key for decryption, right? So this is called a public key and this is called a private key, and vice versa. And by this way, even if one of the keys is compromised, this text could not be decrypted unless and until we have that private key, right? So this is how encryption works for asymmetric key. So that's for cryptography. I want to talk about firewalls now. This is the last topic of our course, and I'm excited to finish it, right? I'm sure you guys are also excited. A lot of students might be taking a sigh of relief that finally this course is over. It has been a long journey, right? Alright, so firewalls are actually, I have an example, maybe I don't have it. Okay, so firewalls, what firewall does is, it basically is either a software or a hardware that inspect whatever is coming into your network. So if this is your network, for example, this is your LAN and this is the internet, and your LAN is connected to the internet, there is a firewall in between that checks each incoming packet and each outgoing packet. If some of the packets are malicious, this firewall will stop them over there. Now this firewall can be a separate hardware, it can only be a software on your system, or nowadays this firewall is normally inside your router, right? So router actually is taking care of all these things. Most of the modern routers, they have firewalls in them. Even if they don't have, your operating system has built-in firewall in them, right? So this router checks each packet and it can stop them. Even some of the things, for example, if as a parent you want to stop your kids from going to certain websites, you can stop them at the router level. You can also stop them at the operating system level as well using the firewalls, right? And how they actually work, we're going to do an exercise on that. So I'm going to do a couple of things, 1 or 2 things maybe, and you do the other things as an example, right? So let's see how we can add rules to our firewall using Ubuntu in Linux. So what we can do is, there are several utilities that you can use for for firewalls in Linux, the built-in one is IP tables. And what it does is it is normally installed by default in Ubuntu, but if it's not installed, then you can do sudo apt-get install IP tables, right? So you can do that. Now what I want to do is I want to show you the info for IP tables first. So in IP tables there are a lot of things that you can do, and this info tells you how exactly you are going to use it, what other things you can do. It's very detailed, so you can use it, and it's pretty handy. And you can do a lot of things with it, but what I'm going to do is I'm going to quickly show you a few things over here. So I want to see what rules, I want to use maybe sudo over here, what current rules do I have for my firewall in Linux. So I will do IP tables -l will show me the list of all the rules I have. Normally there are three types of rules. One is the rule for incoming connections, we normally call it input. The incoming connections, we normally call them input. In Windows we call them inbound and outbound. Then we have for output, we have the connection, the things that are going from my computer outside, the packets that are going outside of my computer, we normally call them output. And there is a forward that is normally used for routers. If your computer is working as a server as well, this is used for that, for forwarding purposes as well. But I'm not gonna talk about this. I'm gonna talk majorly about input, and for output you can try it yourself. And I've given a couple of exercises that you can. It's not a couple of exercises. I mean, this is one exercise which has a lot of things going on inside. I'm gonna do one or two of you for you, and rest of them you can try it yourself. So what I want to do is I want to, okay, let's see the example. Write a firewall rule for Linux to do the following. Input rule. So I'm going to create an input rule which is drop packets coming from a specific IP address. So if you see over here in the list, I do not have anything over here in the list, right? So my list is pretty clean. It's just showing me the target, and that is, there is nothing that is blocking. I am accepting the packets from all the connections from the internet, everything, right? So I'm accepting everything. There's nothing I'm blocking, and I'm just allowing everything to go out as well. Whenever I'm typing a website, I'm just going to that website, so I'm not blocking anything, right? So what I'm going to do is I'm going to block one of the IP addresses, and then just going to see how it works. So for that, what I'm going to do is, first of all, let's see on my Fedora. I want to have, so let me open terminal. I want to ping my Ubuntu just to see if the connection is built properly or not. So there is a command ping. We know this, it's pretty famous, 192.168.0.12. This is the address of my Ubuntu. So you can see that I'm getting the response from my Ubuntu machine, right? So I'm going to stop that. And what I want to do now is I want to block this Fedora for entering or sending any packets to my Ubuntu machine, right? Right now you can see that I can send packets, right? What I want to do is I want to just block IP address of Fedora on my Ubuntu. So to check the IP address of my Fedora machine, I can do ifconfig, and this is the IP address. So this is the IP address of my Fedora, and 12.12 is the IP address of my Ubuntu. Now in order to, let me clear this. Now in order to add rules to IP tables, add inbound rules to your firewall, if you are more used to terminologies in Windows, this is how we say it in Windows, inbound rules and outbound rules. We can do IP tables, then -a. -a means I'm going to add a rule or append a rule, right, to my current listing, right? So -a is for adding or appending a rule to my current listing, right? So this is for -a is for appending or adding the rule to my current listing. Then I'm gonna say -s. -s is for the source. The source I want to maybe block, so I'm gonna say the right here the IP address of my Fedora. And what I want to do is I want to use the -j command, which means that I want to block something, and that is for drop, right? So what I want to do is I want to drop anything that is coming from this IP address, and I'm going to add this rule to my IP table list. So if I do this and press enter, there is a problem. Okay, so bad argument. I think I missed one argument. Yeah, I missed one thing, which is input. I need to tell if this is an input rule or output rule, if this is an inbound rule or outbound rule. So I have to put an input here, and if I do this, now this rule will be added to my list. So if I do check the IP tables -L list of my IP tables, you can see that I have a list is added, I mean a rule is added, which means that drop everything coming from this IP address from anywhere, right? So this is what I say. So anything coming from this IP address, drop it, drop those packets. So if I go back to my Fedora and I try to ping to this my Ubuntu machine, you can see that it's not pinging, right? It's not pinging at all, which means that the packets are not reaching there, and ping means go to that machine and bring the packets from there, right? And I'm not able to bring that, right? So if I do Control C, obviously you can see that I have not, this machine has not, it has sent 15 packets, but it has not received back any packet from Ubuntu, which means that the packets were blocked by Ubuntu and there were 100% packet loss, right? So this is how you can add packets to your, add rules to your IP tables, to your firewall and Linux. And -L is a command for seeing it. And what else? Let me go back and see. What you can do is, okay, the rest of the things I'll leave it to you. What I'm going to do is I'm going to flush this rule or delete the rule, right? So I mean, there are different commands for flushing and deleting the rule. I'm going to flush the rule. It will flush all the rules I have in IP table, and then it should be able to receive packets from my Fedora machine. So what I'm going to do is I'm going to flush this rule. So I'm going to do IP tables. I think it's flush or -F if I'm not wrong. -F, I guess. -F. Yeah. So if I see my listing again, you can see that that rule is not available anymore, which was this rule. And if I try to ping again from my Fedora machine, you can see that it's pinging now. So if I close it now, you can see that it has transmitted 4 packets and it has received 4 packets, and there is 0% packet loss, which was 100% previously. Packets were not received. This is how you actually work on your firewall, and this is how you can create inbound or input rules in your firewall using Ubuntu, using IP tables. There are other utilities as well, you can use them. You can use GUI as well. Try to do that yourself as well. I have few things for you written over here. Try to do it for a specific IP address. I did the first one. I draw packets from specific IP address, accept packets from IP address. You might have already guessed how to do that. Then for a specific port, you can do that, accept it or drop it. I did flush for you. And delete, you can delete. Give priority, it's another one. I've used -A over here. If you want to give, if you put -I over here, it will put your rule on top. You might have 10 rules over here, and this rule you added will be added to the end if you use -A. But if you want to add this rule to the top of it, instead of -A, you can use -I. So this is it for firewalls, and I guess this is it for this course. We have done pretty good job for this course. Again, thank you very much for listening to all the videos, and I really appreciate you guys submitting your assignments on time, and I can see you guys are taking this course seriously. Again, this course is tricky. This course can become serious pressure, but I try to keep it simple for you. I try to make sure the concepts are understandable for you. Things are making sense to you, and as I said that I try to give you as many exercises as possible. We could have done almost all the topics we studied in this as exercises, but obviously because of time constraint we cannot do that. So I picked few of them for you that we can actually program, and we did program them, and we have seen how those concepts actually work. So I believe that if you understand these concepts are going to help you in your capstone as well, because now hopefully by the end of this course you know a lot about how operating systems work. And this is a very good opportunity when you're doing your undergrad degree, when you're doing your bachelor's and you're developing a capstone project. It gives you a lot of flexibility of developing different type of projects when you study courses like operating system and data structure and programming in general, and networking courses in general. because they give you a lot of information, a lot of background about a lot of technologies that are currently being used in market. So that's a very good opportunity for you in Capstone to develop something that can actually help you showcase your talent and skills in market during the interviews. You might have seen that all these things like Facebook and everything, they were just capstone projects, right? So you can make something big like that. There are a lot of startups going on, and in Canada we have lots of opportunities. There are so many incubators around that can help you actually build your own stuff. So do look into these. There might be some questions for you. I can see that in dining philosopher problem in assignment number 2, some students actually disregarded all the existing solutions and they said that none of them are good. Obviously none of them is perfect, obviously, for sure, but obviously you might come up with something which is far better than the existing solutions, and maybe after 10 years I'll be teaching an algorithm which was developed by one of you, for example, right? Or why don't I develop it, right? So I hope this course has given you a big spectrum of how things actually work, a lot of exploration about how computers work in general, how operating system works specifically, what different responsibilities are there, and you have already seen that what are the limitations of operating system, what are different algorithms operating system is using, race conditions and deadlocks. You might come up with some algorithm, as I said, that can avoid race conditions and deadlocks. So possibilities are immense when it comes to operating system because this is a software that everybody is going to use. There are browsers around. Some of the people, they use Chrome, some use Firefox. Nobody in this world uses the same browser, right? Although there are very limited browsers available. Similarly, operating system, there are very few choices for people to use. So people are going to use operating system, and most of the concept in operating system, they are similar throughout the operating system. Almost all the operating system in Word, they use processes, the threads, and memory management and so on. So just make sure that you understand these concepts. As for your exams, I've already told you that I'm going to explain that in next week lecture. So I'm going to go through that exam. So if you have any questions, if you think I should explain you something, some revision, let me know so that I can include that in next week's lecture as well. So I'm going to give you some important topics as well that you should think of before going to final exam in the next lecture as well. So I'm going to give you a list of topics that you should at least go through before going to final exam. So consider them as a hint to your final exam as well, so that you don't have to go through each and every topic that we have discussed in this course. So I'm not gonna give you a tough time in that. So I'm gonna give you some topics that you should work on. So I'm gonna make sure that those topics are the only ones that are covered in final exam, because I know it's a very, very detailed and comprehensive course, and I don't expect you to know everything on that single day of final exam. So yeah, I'm gonna do that in next week's lecture. But if you're confused about any topic, anything you think you have not understood, this is a good chance. You can just drop me an email and I can revise that again in next week's lecture, because we are not going to have too many things to discuss in next week's lecture. So maybe we can talk about that. And yeah, that's pretty much it. I would like to thank you guys again for being excellent students to this course. I hope this course has made sense to you. I tried my level best to make it as easy as possible, and I hope I succeeded in that. At least I have not gotten too many questions from you guys. Either you guys are very scared or you haven't understood anything, but that is quite contrary to what you have done in your assignments, although they were not that difficult. But at least I can see that you guys have done a pretty good job. So yeah, so again, thank you very much, guys. I wish you all the very best for your final presentations. I wish you all the very best for your final exam, and if you have any questions, just drop me an email or just meet me in my virtual office hours. Might see some of you in coming courses in winter. Otherwise, wish you all the very best for your degrees, for your future. Thank you very much. Have a nice day. Bye bye.